Today, I'm going to teach you the Solidity programming language in less than 20 minutes so that you can become a blockchain master in no time. So you might be thinking, like, how is that even possible? Well, today I'm going to give you a really fast-paced introduction to the really important parts of the Solidity programming language that you're going to use over and over again. And if you learn all of these, you're going to get up to speed really quickly. And even if you know Solidity already, I guarantee you're going to learn something out of this video. So trust me, you're not going to want to miss this. You're going to want to save this video, bookmark it, and reference it over and over again while you're learning the programming language. So before we get started, I put a lot of effort into making this short video just for you. And the only thing I ask in return is that you like this video. That really helps YouTube know that you got value out of it and shows it to more people. Also, subscribe to this channel and share it with your friends. So if you're new around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. And so if you get a lot of value in this video and you want to learn real-world blockchain skills, land your first Web 3.0 job, then I can show you how to do that over at adaptuniversity.com/bootcamp. All right, so with all that out of the way, let's get started. All right, so let's start with the basics. So what even is Solidity in the first place? So it's an object-oriented high-level language for implementing smart contracts. So what are smart contracts? They're the building blocks of blockchain-based applications. So they're called smart contracts because they represent digital agreements and the code cannot change. And that's a feature of the Solidity programming language once it's put on the blockchain. So you can see the example of a Web 2.0 application where you have a browser and a website that talks to a server backend, like a database that may be a server written in Python or PHP. And you have a blockchain-based application here where you have a browser that connects to a blockchain directly, and all the code for that application is written in Solidity with the smart contracts deployed to the blockchain. So the most common use cases for Solidity smart contracts are tokens. So that's one of the beauty of smart contracts, is you can create a cryptocurrency without creating a brand new blockchain. For NFTs, which are non-fungible tokens, which represent in most cases digital collectibles, although there are many other things you can do with NFTs. And then also decentralized finance or DeFi with things like savings and lending, yield farming, trading, and also flash loans. So you can do all these things with Solidity because it's a fully featured programming language or a Turing-complete programming language, and it's relatively beginner-friendly. So let's dive into the features of the language so that you can see how that works. So you can write Solidity smart contracts directly in your web browser. If you go to remix.ethereum.org, you can write all the source code here. You can compile them, also deploy them to the blockchain. So I've got a simple smart contract here called my contract. Okay, so this is how you create an Ethereum smart contract in the first place. You start off with the Solidity programming language version 0.8.0, and then you give it the contract keyword followed by the arbitrary name of your contract, in this case, my contract, and you put all your code inside these curly braces here. So let's start off with the basic features of the programming language, like the data types and variables and functions. So in terms of data types, Solidity is a statically typed language, which means you have to declare the type anytime you're declaring a variable, and that type should not change. And so you can see that here, like we say string, because this is a data type string, and this is a variable called myString, which we assign here. And this is a special variable called a state variable. That means this value is actually written to the blockchain. So when we put this smart contract on the blockchain, we can call it public, which is the variable visibility, and Solidity will give us a function where we can read the value of this outside the smart contract. And you can see some of the other common types here, like booleans and unsigned integers, and also blockchain addresses. And so these are some common types and examples of state variables. So let's talk about local variables. So in order to do that, we have to also look at how functions work inside of Solidity. So you can see an example here. Solidity lets you create your own functions with arbitrary names. We can see these are examples here like setName and getName. And you can see that these functions take arguments like this string memory name. Okay, this just sets the state variable here of example 1. So if I were to call this function, I could update the value of this state variable name. So in this case, this name right here is a local variable that's only accessible inside this function. And this is a state variable, which is accessible outside the smart contract if we call it public. Okay, or you can do getName here. And it's also available everywhere else inside the smart contract. So in Solidity, there are two main types of functions, write functions and then also read functions. So whenever you're writing new information to the blockchain, you have to pay a gas fee. So you'll pay some cryptocurrency fee whenever you call this function. Whenever you read information from the blockchain, it's completely free and doesn't cost any gas. So just like variables, functions also have visibility. So you can see example, this function is public, so it's accessible outside the smart contract. And if I were to reset this function to internal, it would be only accessible inside the smart contract. And here's an example of all the different visibilities you can apply to a variable. So a variable is no visibility, a variable with private visibility, which means it's only accessible inside the smart contract, an internal variable, which is also accessible inside the smart contract, but can be inherited, and then public, which can be called inside, outside, and also inherited. And for functions, you can see that like this. Here's a public function. It can be called outside the smart contract. It can also be called by another function. A private function which cannot be called outside the smart contract but can be called inside of another function inside the same contract. An external function which can only be called outside the smart contract, and an internal function which can only be called inside the same smart contract like this from another function. So functions also have built-in modifiers in Solidity, like view, for example. This means that the contract does not modify the state of the blockchain, but it can read the state, like read the state variable value name, for example. Pure functions, which do not modify the state and also cannot read the state, so they cannot read name, for example. And then also payable functions, which are allowed to receive Ether, cryptocurrency, whenever the transaction is submitted. And Solidity also lets you create your own custom modifiers, which can be applied to functions. So here's an example. You could do modifier only owner. This restricts who can call a specific function. This requires the message sender. The person who's calling the function is the owner of the contract. So you create it like this, and then you apply it to your function like this. So there's one more function you should know about in Solidity. It's a special function called the constructor function, which you can see with this keyword here. So this is a function that's run once and only once whenever the contract is initialized or put on the blockchain. So it accepts arguments just like other functions. You can make it payable. You can send Ether in. It works pretty much like everything else, except you can only call it once. Likewise, there's a few more variables you should know about in Solidity. These are global variables, which are available inside of any smart contract. So some examples are this, which corresponds to the address of the current smart contract that you're coding against. Message, which has a few more values attached to it, like sender, which is the person calling the function. TX, which is the transaction. You can get the origin of that transaction. Message.value, which is the amount of cryptocurrency same with that transaction. We also have block, which is the current block on the chain. You can get the number, you can get the timestamp, the chain ID, and many other values as well. So now let's talk about operators. So a lot of times you're doing math inside of Solidity with value types, and you're comparing those types, or you're adding those types together, doing some math in some way. So you can see it supports basic math like plus, minus, multiply, divide, exponents, modulus, increment, decrement, and here's an example of a bunch of different math operations all in one. You can also check that things are equal, not equal, greater than, less than, greater than or equal to, less than or equal to. This applies for other types, not just numbers. And you have all the other standard logical operators like and, making sure that both things are true, or that either one of these is true, or not, to check that something is not true. And you can use these operators most commonly inside of conditionals to create if-else statements. So you can see an example like this. If this is true, then return this, else return this, okay? You can see it like this. If something is true, return this, and then, you don't have an else condition here. And you can also express this with a ternary expression like this. So Solidity supports arrays, which are just sorted lists of information. You can declare an array like this by giving it the data type, okay? And then you can, declare it in line just like this. You can also initialize an array without a specific size. You can initialize it with a specific size, like this is an example of an unsigned integer array with 10 zeros just starting out. You can see an array of strings just like this. And you can also do things like read from arrays and manipulate them from inside of functions with the normal functions like reading, just like this. This just gets the value out of a given index. There's zero-based index, just like most other programming languages. You can get the length of an array like this. You can add a new item to the end with push like this. You can get the last element, remove it with pop. And then you can also delete an element at a specific index like this. So one of the most common ways to store information inside of smart contracts is with mappings. So these are key value pairs that work like associative arrays or hash tables in other programming languages where you have a key with a corresponding value. So in this case, you have a mapping declared with the mapping keyword. Okay, you give it a key, which in this case is an unsigned integer, and a string, which corresponds to the value. So in this case, this might be a mapping of names where you have a uint like an ID and a string that corresponds to the name that you want to store here. So you can also see a mapping of addresses, just like blockchain addresses. This is pretty common. Balances, where you have an address corresponding to a number of maybe cryptocurrency that's held in the smart contract. An address with a Boolean to see if someone might have voted or taken a specific action. You can also do nested mappings where you give it an address that corresponds to another mapping within this mapping, which might be a Boolean value on whether a user has taken a specific action based on a uint value. And then you can access and manipulate mappings inside and outside the smart contract like this. So public will give you a reader function where you can fetch a value from a mapping by passing in a key as the ID. Okay, you can see an example of a mapping read inside of a function like this simply by passing in the value of the key, and then setting the value by passing in the key, and then assigning a new value like this, and then also removing an item from the mapping by passing in the ID and then calling delete. So Solidity lets you create your own types with something called a struct. So you can create a struct like this and give it a name. This is an example of a book struct. I've just created this out of thin air. So I've created a book struct with a capital B, and I've given it several attributes like a string title, string author, and then string completed, whether I've read the book or not. And then here I can use that struct inside an application like this. Here's an array of books in my collection. Okay, I can add a new book to the collection like this. I can create a new book like this, saying book, then passing in title, author, and saying false that I haven't read it yet. I can push it to the array just like this. And then I can get the book from the array like this. I just get book, storage, book, and then I return the attributes of the book from this function. And I can also mark that book as completed in my collection with its complete function. I read it from storage, and then I fetch the book like this, and then I just mark it as completed, and that will automatically update it. So another feature of the Solidity programming language you should know about are events. So what are they? Well, Solidity lets you subscribe to events from an external consumer to find out anytime a function or something inside of a function has been called. So in this case, we have an event here that I've created called message updated. All right, this has some different arguments or attributes, I should say, the user who called the function and also the message. So you can see that here, update message. It just takes a message and then it updates the message inside the smart contract and it emits the event. So you trigger events like this with the emit keyword and then you pass in the values which you specified here. And so anytime that this function is called, there will be a record of it on the blockchain that I can go back and look at later very easily and by finding this event. So I can also get a notification anytime this function is called in real time because I can subscribe to this event externally and maybe get a push notification or something like that. So I can also get an entire history of every single time this message has been emitted. And that's another useful use case for events as well. So I should also note that these, attributes inside the event can be any data type that you want to. And you can have up to 17 of these. And you can also index up to 3 of these. So what does that mean, index? Well, in this case, we can see indexed user. So that means that I can filter through events or subscribe to events that only pertain to this particular user. So instead of getting a push notification every single time an event is called, I can filter out events that are only called with a specific address in this case. So another thing you should know about inside of Solidity is working with the native cryptocurrency of the Ethereum blockchain, Ether. So you can see different expressions of Ether coded out in the smart contract right here. So Ether is divisible by 18 decimal places. So just like the US dollar is divisible by 2 decimal places, Ether has 18 zeros after the decimal place. So the smallest unit here is Wei. Another common value is Gwei, which is used to pay for gas most commonly. So you can see those in the contract. You can see shortcuts for this. 1 Wei is equal to 1. 1 Gwei is equal to this much. And 1 Ether is equal to 1 followed by 18 decimal places. You can receive Ether directly to a smart contract with the receive function if you call it external and payable. You can also use the fallback function if no receive function is implemented and if MSG or message data is not present. And inside of both of these functions, you can also implement any type of arbitrary business logic that you want. So you can see an example of here as a line that updates this count by 1. You can check the balance of any address inside of a smart contract just like this. In this case, I'm checking the contract balance address this and just calling .balance. And you can also send Ether to a different address just like this with call. Now, there are other ways to do this, but this is my preferred way because you can check for the success of this message and you can add a require statement just like this. And the last thing I'll say about Ether inside of smart contracts is that any function can receive Ether whenever the transaction is sent, as long as you use the payable modifier built into Solidity. And then you can access this value inside the function with message.value. And then also the sender with message.sender. And so speaking of this require statement right here, I'll make a quick note on error handling inside of Solidity. So we'll see 2 examples here. The most common way is to use this require statement. So this is essentially a function inside of Solidity that checks for the value is true or false. So you can see here examples just seeing if a value is greater than 10. If the value is greater than 10, then this function will succeed. And you'll see, everything after this function continue. If this value is less than 10, then this function will stop execution and this error message will be raised, okay? So another common function is the revert function. Okay, so you can see if value is less than or equal to 10, then revert, and then if it's okay, then continue on execution with the function as well. So both these two will get you really far. You can also define your own custom errors and use things like assert, but these will get you started. So another thing you should know about is that Solidity supports inheritance. So you can create smart contracts that inherit behavior from other smart contracts. So in this case, you can see my contract inherits from this other contract called ownable. You can see contract ownable. This basically encapsulates all the behavior of a contract that restricts function calls to the person who deployed the contract to the blockchain, or in this case, the owner. So inside the constructor, we set the owner as message sender. We store it as a state variable here. We create a custom modifier that says only the owner can call a specific function in which this modifier is applied to. So we can inherit that all that behavior inside of our smart contract, and with one line, we can say my contract is ownable. So you can either import this from a different file, or you can just have it in view in the same file. Okay. And then here you can see we have this ownable modifier that we can apply to this set name function. And also note that the constructor right here is going to automatically be inherited from this contract when we put it on the blockchain. All right, so the final thing you should know about with Solidity is how to talk to other smart contracts within a smart contract. So I'll show you an example of that. There's a few different ways. We could see this contract here is a secret vault, which basically just stores a secret on chain. You can set the secret and also get the secret. So we'll see how to interact with that in a different contract. So you can see my contract. Inside the constructor, what we do is take the address for the other contract that's deployed to the blockchain, and then we save it here. So we actually have a type called secret vault, which is the same name as this contract here. It saves it as a state variable so we can access it and call its functions later. So you can see an example of setting the secret. Basically, we just say secret vault. This is the contract that's saved here, and we call set secret, okay, inside this function, and we just pass in whatever, argument we need for that function. We can also get the secret like this, just say secret vault, return, get secret. It's pretty straightforward. Another common way to talk to other smart contracts is to use interfaces. So this is where you don't need the complete code of another smart contract on chain. So in this case, let's say an ERC20 token. This is a common cryptocurrency standard on the blockchain. So all you have to know is the specific functions that you want to call. So in this case, we want to call the transfer from function on the ERC20 token, which you can create an interface for it with the interface keyword, ERC20, and then just give it a description for how the transfer from function works. And then we can use that inside of our smart contract like this. We have a deposit function, which basically just takes the token address and the amount. And then we say ERC20, and then we pass in the token address, and then we can call any function we want to on that smart contract from this right here. We could also say this to a variable if we want to, but we'll just do it in one liner, okay? And then call transfer from, and then pass in whatever values we want to, like the message sender who's calling this function, the address of the contract who might own these tokens, and also the amount which is passed in from the function argument here. All right, so that's an overview of the Solidity programming language in less than 20 minutes. So these are the most important aspects of the programming language that you're going to see over and over again. And if you understand these, you're going to be up to speed really quickly and on your way to becoming a real-world blockchain master. So again, I put a lot of time into making this video for you. So if you got value out of this, make sure you smash that like button down below for the YouTube algorithm. That really does help YouTube show this video to more people. Make sure you subscribe to the channel. And if you like this video, you did get value out of it, you want to take the next step and master real-world blockchain skills, I can show you to do that step-by-step start to finish over at dappuniversity.com/bootcamp. You really don't have to be an expert to get started today. I've helped people with zero coding experience, break into the blockchain industry, land their first blockchain job in a matter of months. So that's all I've got. Until next time, thanks for watching Dapp University.